Okay, so last time we got into thiols, remember? And they're thiols or like alcohols, instead of an OH, you had an SH. Okay? And remember, the important property here was that that hydrogen was acidic. So if we reacted with base, it could easily remove that. And give you the S minus. Okay? This is what's called the thiolate ion. Okay? All right, and what we want to do today is look at the chemistry of this. What kind of reactions can we do with the thiolate ion? Okay. So the biggest reaction we can do is that since the sulfur has lone pair on it, that this thing acts as a nucleophile, and so we can do substitution reactions. Okay? So for example, if I reacted that with, say, that substrate, sulfur attacks, and leaving group leaves. And we get that kind of compound there. See if we can draw the product for this reaction. So what would you have? The sulfur attacking here, kicking off the bromine. Give you right there.
You have to show the two steps here.
Yeah, I wasn't necessarily asking for the mechanism, just draw the product. Okay. So these molecules that we're forming, these are what are called sulfides. Sulfides, okay? So sulfides can be made from thiols. So a sulfide is where I have a sulfur and a carbon on both sides, okay? We'll see they're very analogous to ethers when we study ethers. Let's look at how to name sulfides. Very easy. What you do is you name both sides of it first. So I got an ethyl and a methyl. So I write those in alphabetical order. And then I see it's a sulfide. And just end up with the word sulfide. So I get ethyl methyl sulfide. Okay? And we'll see ethers are very easy to name as well when we get to them. This down here, what could we maybe call that? Well, you got a cyclopentyl and a cyclohexyl. Okay? And then end it with sulfide. Okay? All right, so this is how we make sulfides. Okay? We'll see ethers. Ethers are just like sulfides, except you have an oxygen here. And we'll see that ethers can be made not from thiols, but from alcohols. Okay? But we'll get to that in our next chapter. Okay. Let's look at another reaction that thiols can do. Okay. This is taking advantage of their acidic hydrogen. Okay. This next reaction is going to be completely different. Okay. Here what we're going to do is take two sulfides, or two thiols, okay, and we're going to react it with Br2. See what in the world does that do, okay? The bromine is not going to be part of the final molecule that you might expect it to be. Instead, what you get is this thing here. Where the two molecules join together at their sulfurs. So you get two sulfurs bonding together. Okay? This is what's called a disulfide. Okay? So the purpose of the bromine is to join the two sulfurs together. So you get a unpredicted reaction. I bet you didn't predict that, did you? Okay. Anybody predict that? Did you predict that? Okay. Well, this reaction is more common than you might expect. You ladies in here, raise your hand if you ever got a perm. Shouldn't surprise me. Everybody raise their hand. Okay. Now I won't ask if any guys got any perms. Okay. Did you ever get a perm? No. Okay. How about you, John? No hair today? You played it safe. Okay. Well, it turns out in your hair, you have thiols in there in one of the proteins, cysteine. Okay? And so when you go to get a perm, what happens is they have an agent. They don't use bromine, they use something else. that connects your cysteine proteins in your hair together like that. And when it does that, it locks the hair into place, which you call a perm. Okay? And so that perm is settled in through these disulfide bonds. Okay? Then what you can do to get rid of the perm, they often do when you go in there, you can do a reverse reaction that gets rid of the perm. Okay? Zinc, HCl, that will get rid of the disulfide bond and convert back to the regular thiol. Okay? So there your hair would get limp and it's free again. Okay? So you can go back and forth all you want.
So that hydrochloric acid wouldn't.
Well, yeah, I think they use something different than that for your hair, okay? But in the lab, that's what you could do, okay? You may want to check next time you get a perm what they use. When you guys get a perm, does it burn your head? Okay, so something's going on there pretty powerful. Okay? So they're using a strong oxidizing agent. Ask them what they're using. Okay? And you can see. Okay? Maybe you'll stop getting perms. Okay? Just go like the guys do. Just brush it back.
Or, you know.
Or go the way me and Charlie do. Just get a razor and end it.
Would you date a bald headed lady? Would you,
They have something in common.
Would I date a bald-headed lady?
Like if she shaved her, if she was in the mirror shaving her head right now, would you do that with her?
Consider. I consider. Okay.
Some people can pull it out here.
I may sell the movie G.I. Jane. You shaved her head.
I married her. Hey, who? Demi Moore?
Okay.
G.I. Jane.
She did not look good like that either.
I thought so.
She looked a whole lot better with her hair.
Yeah, striptease looks better.
All right. So you can think about next time you get a perm. Okay? All right, one other reaction here with thiols. And that reaction is a strong oxidation.
So the last one that you just showed us with the 2 sulfides, that was still a substitution reaction?
Not so much a substitution reaction, it's kind of in a different category.
Okay.
Yeah. But here, if you have a thiol and reacted with nitric acid and really heated it up, boiled it, okay? What this does is it converts the thiol to this group here. See all the oxygens that are adding on? Okay? This is called a sulfonic acid group. Okay? So I'm really oxidizing the heck out of it. Okay? Putting all these 3 oxygens on it. Okay? Another way to do the same reaction is use KMNO4 and boil it. Okay? the reaction, advise you to do it in the hood, because you're heating it up, and so toxic fumes are going to be coming off. All right, so this is how we can oxidize the thiol to the sulfonic acid. Okay, so that ends chapter 10. Okay, more reactions with thiols. Now we'll go on to chapter 11. Chapter 11 deals with alcohols as well. Okay, but here it's going to get into heavy-duty reactions of alcohols. Okay, but before getting into them, what they do at the beginning of the chapter is go over some key definitions that we want to look at. Okay, we just talked about oxidation. Let's see if we can give it a formal definition, okay? And as well, what the definition of reduction is, okay? Remember, in general chemistry, oxidation and reduction were based on electron transfer. Remember that? So oxidation, you would lose electrons. Reduction, you would gain electrons, okay? Well, a little bit different in organic chemistry, okay? Let's look first of all at oxidation. Okay. For oxidation, we'll look at 3 different ways we can identify something as being oxidized. Okay. The first obvious way is if there is a gain in oxygen. Second way is if we have a gain in X2. Remember what X stands for? Halogens. Okay? So if we add halogens, that's an example of an oxidation. And lastly, if we have a loss of hydrogen, H2. So those are the 3 ways we can identify something as an oxidation. Okay? Well, how about a reduction? What do you think the definitions are for a reduction? The exact opposite, right? So let's just flip each of those 3 there. So one way is a loss of oxygen. Loss of 2 halogens. Or lastly, a gain of hydrogen. Okay. Turns out to be one other category. What do you think that is? Starts with an N. Neither. Okay. How can we predict that? Well, the book gives nice definitions here. Okay. So, one is the gain or loss of H plus proton. OH minus, water, or an alcohol. Okay, as well as HX. Okay, so if one of those is going on, then it doesn't fall in either category. Okay, so these can be tricky, okay, see? Because I got oxygen going on here. Okay, I got oxygen, so even though I lose or gain, I gotta be looking out, are these things going on? Okay? So let's look at some examples and see if we can figure these out. Okay. Just going to take these right from your book. All right, so once you work on those, okay? If you want to turn and work with a partner, go right ahead. So you can help each other, work in groups of 2 or 3. So you can expect a similar question or questions on the exam.
Oxidation, reduction.
Right. State what they are. You got 1 of 3 choices. Okay. Once you work with somebody to help each other out. See if you come up with this.
Got no waste from those.
Why the oxidation? And it lost so that's neat. Well, cause that might be oxidation. Underneath it says a gain or loss of hydrogen, OH, H2O. That picked up that OH.
Oh, I thought she.
So is it oxidation? How does that mean the first? Keith, remember?
You said it's safe.
Number 3 is
Oxidation.
the oxidation you gave that to two thiols.
Oh, yeah, that'll be oxidation.
I got it. That bottom one got H2O.
You said the last one was
Oh, you like to say so what type I got meat.
The top one over there on the right. You did get oxidation.
But it has
So would they be underneath? Technically.
because
If you gain your oxidation, but it gained the oxidation. It gave you the oxidation. That's what my point right now.
Y'all get to the top right.
No,
Yeah.
top right.
Yeah, top right.
I think I was saying what you did.
What you got?
It gains the oxidation and it gains the hydrogen.
No, it's not one oxidation.
Right, yeah.
Gain the type.
If that's the case, that's a cancel out. I got to, it can't be two. It can't be our
Okay, I'm gonna put, and that's
It gains hydrogen, right? It's two hydrogen.
No,
It
it
gains two
I'm
hydrogen.
talking top.
I
I just put
know it don't matter with it.
the bottom right.
Okay, we got
Oh, it gains two
Manson. Okay. Just gonna call on one person at a time, and everybody answer. And just tell me what you got, and then tell me why you got that answer. All right? Then I'll tell you if you're right. Okay? So, let's go with Jari. What'd you get for the first one here?
The first one I got reduction,
You got a reduction. Why a reduction?
because you gain two hydrogens.
Okay, very good. You gained one here, and you gained one there. Okay? So we got a reduction. Okay? Any problems with that? All right. Let's see. Go with Sade there. What'd you get for this one?
I got neither.
Neither. Why'd you say neither?
Because you gained the OH and you lost the hydrogen.
Okay, well, I got 4 hydrogens here, and I got 4 here.
Oh, I'm sorry, I looked at that. Oxidation. I'm sorry, I looked
So
at
you
it
gain,
wrong.
okay.
Yeah, but you
You
gain
gain
oxidation.
oxygen.
Gain oxygen.
Yeah, so we gain the oxygen,
Okay.
okay? Okay, go with you then.
Oxidation,
Okay, why'd you say oxidation?
because it gained the, halogen, H2.
Let's go in the back there. Did you get through this one?
I said it was needed,
Why is that?
because you got the alcohols when you broke the double bond.
Doesn't
The
matter if
OH,
it's OH
yeah, the
minus?
high.
Okay, so you added OH
Mhm.
to those.
It doesn't matter if it has the, OH minus on it?
Oh, no, it won't have OH minus on it, but that's how you write OH by itself, you see. When you add
So
it,
if it was just one by itself, it would be
no,
considered?
you can just forget this minus, okay? When I write OH by itself like this, I have to include minus, but on a molecule, there's no minus. Okay, try you, this one here.
That one, I got neither,
Neither? Why is that?
because you added H2O.
No.
Then you have
Need some help, what did I add?
ROH?
I added alcohol. See that? Charmaine, what'd you get for this one?
Production, gain 2 hydrogen.
Okay, we gained hydrogen. So reduction. Okay. So you see how some of these can be a little tricky there, but for the most part, pretty straightforward. Okay. All right.
Might be the candidate probably needed.
Well, since we know what these terms now mean,
So it's got this one.
okay, now we can start looking at some of these reactions. The first one is the oxidation of alcohols. Okay. So for example, if we had this secondary alcohol, okay, if I were to oxidize that, what kind of compound would I get? What would the OH turn into? A double bond O. Okay? So that's what oxidizing alcohols does. Turns it to double bond O, which are called carbonyls. So we need a reagent to do that. Here it is. It's a mixture of this, which is called sodium dichromate. chromium. Chromium is a oxidizer. And then we also use sulfuric acid. Okay. Sulfuric acid by itself is an oxidizer. So now when I combine both of them, I get a super oxidizer. Okay? So this oxidizes the OH to the carbonyl. Okay, same kind of thing here. If you have two OHs, what do you think that reagent does? It converts both of them. To give us something like that. All right, so any questions on the oxidation of alcohols? Very simple reaction, but yet a very powerful one. Okay, let's look at one last thing here and call it a day.
It's a beautiful day today.
Okay. Here we'll look at alcohols as nucleophiles. Okay? This is some of the main chemistry of alcohols we're going to study in this chapter. Okay? So for example, by that alcohol there, methanol, could that act as a nucleophile?
It says alcohol is nucleophiles.
Okay. What?
But yeah.
Yeah, it may not be telling the truth here. Why can this act as a nucleophile? Lone pair. Okay. So that means it can act as a nucleophile or a base. Okay. But let's compare that to that there, the methoxy. Could that act as a nucleophile?
Yeah.
Sure, I got lone pair again. And it could act as a base. Well, which one of these two could be the better nucleophile? Why this one? Because of the negative charge, not the extra lone pair, because of the negative charge.
It doesn't have a negative charge because of the extra one.
It does, but it's the extra lone pair. Well, you know, it's a circular argument. Try to be funny over there. Okay, talk to you after class. You're a class clown. Okay, so yeah, so when I take that hydrogen off, I get a better nucleophile, okay? And that's what we want to do, is start taking advantage of that and see what kind of chemistry we can do with that. Okay? Do you remember how to convert the alcohol to that? What do we use? If you were here. What was one? Everybody remember how to do that? Okay? You use what, sodium,
Converting to oxidol.
potassium, or
No, not lithium, robotic sodium.
Sodium hydrate.
sodium hydride. Okay, so any one of those will take that hydrogen off and give you O minus. Okay, so I gave those to you earlier, and we're gonna start using them next class period. Okay? So let's stop there for today, and we'll see you on Wednesday.
How many FG